Hello everyone. Now let's look at another LeetCode practice question. Today we are looking at problem 143. Reorder list. You are given the head of a single linked list. The list can be represented as L0 pointed to L1, blah blah blah, Ln minus 1 pointed to L minus Ln. Reorder the list to be on the following form. L0 point to Ln, point to L1, point to Ln minus 1, point to L2, and then Ln minus 2, so on and so forth. You may not modify the value in the links node. Only nodes themselves may be changed. Okay, so we cannot modify the linked list value, but we need to change the order of the nodes itself. Okay, so let's look at some examples there. Examples 1, we have 1, point to 2, point to 3, point to 4. Okay, this would then be 1, point to 4, point to 2, point to 3. Sample 2, we have 1, point to 2, point to 3, point to 4, point to 5. This would then be 1, point to 5, point to 2, point to 4, point to 3. Okay, so I think I understand the problem now. I would like to ask a few clarifying questions. How many elements? May I assume that there will be at least one element in the linked list? The answer is it could be between 1 to 5 times 10 to the power of 4. Okay, I think I understand the problem now. Let me think about some possible approaches. So, one off the top of my head, well, since we now need to reorder it into, I think the best way is that if I have a reverse linked list, if I have the reverse linked list, then I could do I could basically take one element from each pointer alternatively until it exhausts the list from the original linked list and also the reverse linked list. Meaning that if I could, firstly, I could cut off the linked list into two, and then I am gonna reverse the linked list of the other half, I mean the second half of the linked list after I cut it off. And then I'm gonna iterate and pick an element from each linked list alternatively until I it shows all the nodes in both lists. I think that could work. Does this sound reasonable to you? I would like to start implementing this unless you would like me to explore further optimizations. Okay, I think this sounds reasonable. Let me see how we can do this. First of all, thinking of whether I should go through all the elements. So I'm considering whether, I guess there are a few ways to do this. One better way is, I have described one before, which is using two different lists. One is moving forward and another is moving backward. I think I have a better idea. Instead of creating a copy, I could instead reverse the list in place. Right. If I can find out the middle point, and then I could basically to reverse a linked list is not a difficult task. So if I do my first look, when I go through the linked list, I could determine the cutoff between the cutoff so that I could know the middle node of the list, and then I could iterate through the list for the second time, but this time when I reach the middle node, I'm gonna start reversing the linked list so that the first half is moving forward, but the second half would be pointing backward compared to the original input. And then, so I'm trying to come up with a O1 space solution because I kind of find it interesting. And so let me try to write down my steps here. So first, determine the mid. Okay. Second, reverse the second half. And then thirdly, modify the next element alternatively. Is that even possible? Yeah, I think I could reorder in place. So let me go through the example one. We have 1, 2, 3, 4. The mid is at, let's say I'm gonna put it at 3 here. Or can I put it at 2? 4 divided by 2 is 2. Okay, so the mid is 3. And then what I'm gonna do is I will revert the second half, which gives me 1, 2, 3, and then 4. So now I could take one element from each side, one at a time. So left, right. Gonna move it to left, and then right would be none. So I will have 1 pointed to 4, pointed to 2, pointed to 3. When I could just put the mid to mid as part of the right, the second half of the list. So right, left, right. Okay. Yep. So I think this work. Then let me try with the second examples. We have 1, 2, 3, 4, 5. So there are 5. The mid would be at 5 divided by 2. It would be 2. So the mid is 3. And let's see what we got here. When we reverse it, it's gonna be 3, 1, 2, and then the second half would be 5, 4, 3. So now let's try to construct the output. We have left and right. Move it forward. Left and right. So 1 point to 5. Now this is pointing to 2, pointing to 4. And then the 3. 1, 5, 2, 4, 3. So that is correct. How about the edge case? Edge case, we have only 1. So the mid would be pointing to itself. And then the left and right would, well, the left would point at empty, and then the right would be itself. Okay, so there would be just one. I think it should work. Does this sound reasonable to you? I mean, I am pretty good about this. I would like to start implementing, unless you would like me to explore further optimizations. I think this is good, so let's try to write the code for this. Okay, so let me just walk through the whole list to find out the mid. So I'm gonna do length. I call it, let's see, what do we call it here? Count. Okay, let's use count to be 0. Then we will look through the list. While head count plus equals 1, head equals head dot next. Okay, so we cannot use head because we will lose the head. So let's just create curve. Okay, so use curve, curve, curve. Okay, at the end we have the count. Then the mid mid would be count divided by 2. So essentially here I'm using the mid as the head, I mean the last node of the second half of the linked list. So that would be, well, that would also mean it would be the last node of the backward linked list. Okay, so let me just get the tail of it so that we know which when we should start reversing the order. So while I less than mid, so I is 0, while I is mid. Okay, don't forget the curve head. So I plus equals 1, curve equals curve dot next. And then we would have I equals to the mid. So then, what do we do now? Okay, so we also need the pref so as to cut off. Yeah. Curl equals curl dot next, and also pref equals curl, and then at the after the loop the curl would point at the tail of the second half, and then don't forget to set the pref dot next to none because we have cut off the ties, and thus we have two linked lists. So what do we do now? We have curl pointing to the tail. Okay, so now what we need to do is okay, so now pref will point at curl, and curl will point at curl dot next. Okay, so what do we do now? Now we need to reverse the linked list. And how are we going to do that? Well, first of all, we will use the curl point to the pref, and then the pref okay, so now we also need to set the curl. Okay, so pref equals none. Hold on. Okay, so now we can, let's see, we can reset the pref and cur. So pref equals none now, cur equals C. Cur will still be at the same node, and then what you're gonna do is we will do a while cur pref and cur sorry about that, I was lost a bit. So we have pref and cur. So you want to set the cur.next to point to the pref. Then at the same time, we want to move on the cur to the next one. Okay, so I guess we could use a next variable. So the next is cur.next. And then the pref will set to cur dot next, I guess. Let's see how we're gonna do this. So now I have the next value. Point it back. Okay, so cur.next would be the pref, then pref would be cur would be next. Okay, and then this time I will have pref to be the second half. Right. Yeah. So I'm gonna call another variable head1 and head2. So to avoid confusion, the head1 would be head2 would be the pref. And I will add on all of it. While head1 and head2 left right is head1 head2 1 2 equals the next. Then we move on. Head 1 point to head 1 dot next. Head 2 point to head 2 dot next. In the end, I'll check again. If head 2, then I forgot to link everything here. So left dot next equals right. I guess I'll also need a curve. Curve equals head 1. Yep, so left of next would be the right one. And then curve. Let's see. Okay, so curve should be initialized to empty node, so that it is more convenient for me when I set the curve dot next equals left. Left dot next equals right, and then curve would point to right. Okay. At the end, I'm gonna check again if there is head 2. If so, then curve dot next equals head 2. Then I'm gonna just return the head. Okay, so let me go through the code again to make sure I haven't missed anything. First of all, I use count to see how many node is in the linked list. So I keep counting and then I get the mid. The mid will be the count divided by 2. And then I'm gonna get the pointer to the mid value in the middle node. So yeah, and then I'm gonna start reorder the second half of the list so that it is reversed. I do it by using a while loop. So while head 1, so sorry, previously when I get to the mid middle node. That would be the tail of the reversing list of the second half. So now I'm gonna use the curve and then keep on iterating while also reversing the list until the end of it. Then when I reach the end, I also reach the head of the reverse list from the back. At this point, I just need to reorder the linked list so that it is so that we achieve what we want in the question, which is by appending the left and right alternately. Then towards the end, I just return the original input head. This is assuming that I can reuse the input so as to save some space. I think that's reasonable. So now let me test the code with our input. So firstly, I will have 1, 2, 3, 4. The mid would be 2. And then I'm gonna start at 0 and move it forward. Curve is now at 1, index 1, pointing at value 2. Then at value 3, we break it. So let me just write it down here. 1, 2, 3, 4. The mid. Then I would have curve prime. Now I would have 1, 2, 3, 4. Head 1 would be there. Head 2 would be there. Then I keep adding, so I think this works. So 1. So first of all, I'm gonna start at now, point to 1, point to 4. And the H1 will move there. Point to 2, point to 3. So I think this works. For example, for 1, 2, 3, 4, 5, mid would be at 2. So 1, 2, 3, 4, 5. Then head 1, head 2. We start at empty. Point to 1, point to 5, point to 2, point to 4. And then the last if will handle the pointing to 3. So that also works. Third example, there is only 1. Mid would point at 1. So we would have left is empty. Head 2. Okay, I think I need to handle this edge case. Let's see. If head 2, then cur.next is head 2. Hold on. Cur.next. So cur is an empty list and then it points to the head. Yeah, so I think that works too. Now let me try to code it in a LeetCode to see if we got it right. Yeah, so in here we got a comment that we need to modify head in place. So we don't need to return anything. We cross out the return. So first of all, we count it. Where is head? While head. And while curve. Curve. Count plus equals 1. Curve equals curve dot next. Then the mid would be count divided by 2. Then I'm gonna go towards the middle. So I start at 0. Curve, curve, and curve. So curve S started at none. Curve will be the head. Now the while I less than mid, I plus equals 1. Curve equals, this would be the curve, and curve dot next. Here. Actually, I just need to start at 1 step. Yeah. And then I can move the plus. Let's see. I is at index 0. Okay. Then it's good. What if I use a fast and slow pointer instead? Will that work? Let me think real quick. Okay, so I think that's just confuse everything. Now let's just do it this way. It's a bit tedious, but I think I'm avoiding all the edge cases. I could avoid some edge cases if I do it this way. So let me proceed with this. So now my current is at the middle one. Now I need to reset the pref.next to point to none. So now I have cut off all the ties between the left half and the second half of it. Then gonna do while first of all, don't forget the pref is now none. Now while cur.next is pref. Just store the next first, and then pref.cur. This would be cur. Then the cur would be next, and also cur.next equals pref. Okay. Yep. Then this should work. Now I'm gonna initialize another variable. This is for iterating both of the linked list that we have split from the original input. So head1 and head2. Now this would be head, and then the head2 would be the cur. Hold on, is it? Yeah, so it's pref. Then while head1 and head2, I think we could just head2 here. Now we can do that because that's not how we split. Yeah, that's not how we split it to work in our case. So let's proceed as we planned. Let me do this. Cur is this node. Set this node. Yep. Then I'm gonna store it. 1, 2, and 1, 2 equals 1.next, 2.next, cur.next. Now this would be left. Left.next equals right. Now cur now points to the right one. Then in the end, if there is head2, cur.next would be the head2. Yep, let's try to run it. I think I will get some error. Let's check got it correct. That's amazing. But just to be safe, I would like to test some edge cases. If there is one here, hopefully it's correct. So that I have no next. Where do I call the next? Okay, so pref none. Right, so I need to handle that edge cases. And why don't it work here? So pref is none. But the I is less than mid. So what happened there? Should I use an equal? Well, actually no. Okay, so this is about the Yeah, so I should only execute this if I go inside the loop. Otherwise, there is no point. So let me just, for easiness, for simplicity, I'm gonna check if not at the next return. Okay, let's try to submit it. I got it right. And yes, I got it right. Okay, let's look at some other people's solutions that are pretty efficient. Let's see what they do over there. Why does it look like they are doing about the same thing that I did? One else, yeah. Except that they are doing the one optimization that I mentioned before using fast and slow pointer. I think that is a bit faster. So here we find the mid, we first the second part, and then merging both. So I guess that is also what I am doing. Okay. Alright, I think logically, algorithm-wise, people are doing almost the same thing. Yes, some people are just using the fast and slow pointer to find the mid instead of what I did. Okay, sorry for extending this video a bit long, but hope you get the idea. Thank you.